Okay, so now what we want to do is we want to look at the concept of differentiation as a limit. So before we look at these concepts, I just want to remind you of something. So let's say we have, again, a set of axes, and we have a line on that. So here what we know is whenever I'm trying to find the gradient of this line, what I can do is I can choose any 2 points that I want on this line. So let's say the first point is x1, y1, meaning that this value here is x1 and this value here is y1. That's a value that corresponds here, that's a value that corresponds here. And the second point, let's say the ordered pair corresponding to that is x2, y2, meaning that this value here is x2, and if we extend that, this value here is now y2. Okay? So again, what we do know is whenever I'm trying to find the gradient of a line, all I need to do is I need to find out what's the rise and what's the run. So this distance here is rise, and this distance here is run. Okay, so how much has it risen between these 2 points and how much has it ran between these 2 points? So my gradient would be rise over run. Perfect. So now if I want to think about the rise in terms of the y values that I have, it's basically just this distance, true? So this point here corresponds to y2 and this point here corresponds to y1. So basically this distance here is just the distance between these two values. So if I want to find rise, it's just going to be y2 minus y1. Okay? And similarly, if I want to have a look at this distance here, I say, okay, what does this point correspond to? What does this point correspond to? And to find the distance between them, all I need to do is I need to find out what the difference between x2 and x1 is. So if I do x2 minus x1, I will be able to find that. Okay, so you already know this. This is just a description, an explanation of how it works, just so you have a deep understanding of it. So the gradient here is equal to this formula. Now what we can do is, this is basically the same concept that is used in differentiation as a limit. So now what we look at is, we'll just have a look at how that actually works. Let's say we want to find the gradient of a curve. So let's say this is our curve. So this is the graph of y is equal to x squared. It needs to be a bit smoother, but whatever. Okay, so this is our y is equal to x squared graph. And what we want to do is we want to find the value of its gradient at point x is equal to 2. Okay, so at this point, we want to know what is the value of its gradient. So what we've said before is that at that point 2, what you'll do is you'll draw a tangent to this curve, meaning that the line, you draw a line that is going to only cut through your curve at one point. So that's the kind of curve that you're going to have. So it's only going through your curve at one point. We'll just get rid of this other line. That wasn't very good. Okay, so now that we have that, what we want to say is, okay, I know that the gradient of this curve at that particular point x is equal to 2 is basically the same as the gradient of this tangent, right? So one way that I could have found this value would be to just try to figure out what's the rise and run of this tangent, and then I'd say, okay, my m is just rise over run. But it's kind of hard for us to be able to find what's the rise and run accurately. So one thing we could do is we say, okay, I can just have an estimate. So if this is my graph and this is my x is equal to 2, what I could find is I could find another point on this graph and say, okay, I will just draw a line that goes through both of these points. And now what I can do is I can just find the gradient of this line. Obviously, the gradient is going to be different, but look, it might just be close, right? So the advantage of doing something like this is that you know the exact points and therefore it's easy for you to find this formula. So for example, if this was point 2, then I know that in a graph of y is equal to x squared, when x is 2, your y value is 4, reason being that y is equal to x squared, so 2 being squared and 4. Okay? And if this is x is equal to 1, let's say, we know that that corresponds to 1 squared, which is 1. Okay? Now I have two ordered pairs, which are 2 and 4, and 1 and 1. And to find the gradient, I just simply need to just do 4 minus 1, 2 minus 1. And that's just 3 over 1, which is 3. Okay, so that's the basis of it. Okay, so our aim is really to find 2 points. But realistically, this line, the gradient of this line is quite different to that line. So what we could do is we could bring this second point closer to our x is equal to 2. So the closer we can bring it towards x is equal to 2, the line that we draw, we call it second. So this line is called second. So, and it's right, second. Okay, so if you try to draw these lines, then you can see that as this second point gets closer and closer to your x is equal to 2, the gradient becomes closer and closer to the actual gradient of the tangent at x is equal to 2. So basically that's the basis of differentiation as limit. So what does that mean?